A support agent in one of my systems timed out while adding a customer note. The note actually saved, but the API response never made it back. The loop saw a timeout, retried, and posted the same note again. Not catastrophic, but embarrassing. Now replace that note with a refund, a Slack escalation, a database migration, or an email to 10,000 users. The retry was not the bug. The step was unsafe to retry. That is the scar behind idempotent automation. Agent loops retry by design. Networks fail. Tool calls timeout. Models produce malformed arguments. Workers get killed during deploys. Rate limits clear after a backoff. If your recovery move is run the same step again, then every step must tolerate being run again. Naive automation treats a tool call like a clean transaction. Either it happened, or it did not. Real systems live in the middle. The external service may commit the change and drop the response. Your process may crash after the write, but before saving local state. Without idempotency, the safer loop becomes the dangerous loop. Idempotency means running the same operation twice has the same effect as running it once. In automation, I use a practical version. The same step, for the same target, with the same intent, must not create a second side effect. That does not mean the code never executes twice. It means the external mutation happens once, where the second run detects that it already happened and returns the existing result. The core rule is simple. Check before write beats write and hope. Add a durable record, usually called a ledger, so the loop knows what it planned, what it applied, and what it verified. Mechanically, build each step around an idempotency key. That key should describe the operation, the resource, and the version of the intent. First, read your ledger. If this key is already verified, return the recorded result. If it is planned or applied, reconcile before doing anything new. Second, verify the remote state directly when possible. Does the branch already exist? Was the invoice already created? Is the comment already present? Third, reserve or record the intent with a unique constraint. Fourth, perform the side effect. Fifth, store the external reference and verify. If the worker dies anywhere, the next run resumes from state, not from memory. Take a coding agent that bumps a dependency and opens a pull request. The idempotency key is repository, dependency name, old version and new version. Before writing, it checks the ledger. Then it checks the remote repository for a branch named by that key. If the branch exists, it does not create another branch. It verifies the commit content. Then it looks for an open pull request from that branch. If one exists, it stores that pull request number. If not, it creates one. For the status comment, it includes a hidden marker or stable footer. On retry, it searches for that marker and updates the existing comment instead of posting a second one. Idempotency is not magic. If your key is too broad, you suppress legitimate work. If it is too narrow, you still duplicate. If the ledger is down, you need a policy. Fail closed, to for later, or run a read-only reconciliation pass. Some external systems do not let you search by your key, so you may need an outbox, a stable name, or a provider-supported idempotency token. Randomness is another trap. If the step regenerates different content on retry, the intent changed. Persist the chosen payload before sending it. My opinion, prefer boring, stable identifiers over clever matching. Idempotency sits right next to the other foundation patterns. Retries are only safe if the retried step is idempotent. State is only useful if it survives crashes and tells the next worker where to resume. Verification is what turns I called the tool into I know the world is in the desired state. Budgets matter because even idempotent retry can waste money, hit rate limits, or hide a deeper outage. Later, at fleet scale, this becomes orchestration. Leases, queues, dedupe windows, outbox tables, and reconciliation jobs. But the habit starts here, one step at a time. Here is the 10-minute exercise. Pick one automation you own that writes to anything, sends an email, creates a ticket, updates a file, charges a card, posts a message. Write down the idempotency key for that step. Then write the check you should perform before the write. Next, sketch a ledger row with step ID, target ID, key, state, external reference, and last verified time. Finally, run the ugly thought experiment. The process crashes 1 millisecond after the external write succeeds. What will the next run do? If the answer is, maybe write again, you found the work. 3 beats to keep. First, retries will happen, So design every agent step as if it will run twice. Second, check before write and keep a durable ledger of what was planned, applied, and verified. Third, order the steps as side effects come after validation, and a crash leaves a resumable state instead of a mystery. This is foundation work. It is not flashy, but it is the difference between a helpful agent and an expensive repeat button. New loop engineering episode daily on this channel, moving from foundations to fleet scale reliability.